In the last lecture vignette, we talked about the history of people in North America with a particular emphasis on how the loss of indigenous management regimes has contributed to our wildfire problem in California. What I'd like to do today, or for this vignette, is to talk about some other examples of succession and try to link more strongly the differences, the effects of particular disturbances on how forest systems change over time. Okay, so what we're trying to do here, what we're focusing on in terms of learning goals, is the basics of successional theory. Kind of try to give you the tools to answer the question, how do different starting points influence the outcomes that we see? And point out, and something that's really helpful, is to identify this characteristic that's common in forests, which is that stands develop along predictable lines. And that's something that we can use in management. It can be the basis for our silvicultural systems, which is the topic that we confront last within this course. Some other things that we're going to kind of point out and try to illustrate: the degree of change depends on the severity of the disturbance, another helpful tool, and that disturbance can be strong enough even to change ecosystem types. There, we have identified a significant conservation problem in forest ecology. If we want to maintain forests, it's good to know how we can royally screw them up. All right, so the first example that I want to talk about today is the Northeast, New England. In New England, there's a research station in Petersham, Massachusetts, where I used to work. It's called Harvard Forest. It's part of the university. It's the university's research forest, a really cool place. And it's got this great museum with a series of dioramas. And, dioramas, probably made them in elementary school, grade school. These ones were made in the 20s, if I recall correctly, and they are fantastic works of art that tell the story of changes in forest dynamics in New Zealand and in New England, the other new, British colony, one of the other new British colonies. So anyway, this story starts off with a pre-European forest. It was different than the post-European forests. It's oftentimes portrayed as primeval and untouched by human hands. As we talked about last week, and particularly for the reading this week, that's probably not true. It is certain, however, that it had a lot more trees than it would just a few decades after Europeans arrived. Now, what happened when Europeans arrived? Well, let's look at the next diorama in this sequence. People arrived in the New World, fleeing political persecution, trying to make a better life, the usual reasons that people leave their home countries when they don't really want to. And they started to clear land and establish an agrarian society in New England. This happened in many parts of the Northeast. It was hard work. The soils weren't great. There was a lot of rocks. People built these rock walls. They're kind of cool. You can see them all over New England and in New York. But the soil was good enough. The land was good enough. And there was a pretty extensive and relatively well-off agrarian society that developed. People could make it work here. As a result, and I'm skipping a lot of this here, most of the entire landscape was cleared. Something around 95% of New England was cleared at the height of agricultural development there. Building of relatively large houses and barns and so forth. However, when roads were opened up into the Ohio River Valley, much of the agricultural economy in rural New England collapsed because it was cheaper to ship grains from Ohio, where the agricultural production was much greater, than to produce them locally in New England. So a lot of the agricultural society moved towards perishable things like dairy, and there's still a tradition of dairy in Vermont. and the other kinds of grains, the agricultural economy collapsed. So what this diorama is actually showing is just not very long after the peak of the agricultural economy in New England. And what you're seeing here is the reestablishment, the reinvasion of forest species into cleared lands. And what's interesting in New England, it's really relevant for us, is that what happened on this land influenced which species were able to establish. So what you're seeing here is a pasture, and this pasture is being invaded by pines. Pines are more effective invaders. In New England, white pine is a more effective invader of a pasture, of an area that's dominated by grasses. Now in this tilled land, because it's more nutrient rich, it's actually more likely to be invaded by native hardwoods. So what happened on a particular piece of ground influences the forest species composition that you see in New England today. Isn't that cool? This is peaking, I feel like 1850 or so. I can't remember exactly, but yeah, you go out today, and if you find a stand of white pines, it's very, very likely, in Massachusetts, in rural Massachusetts, very likely that you're looking at an area that would have been pasture. And likewise, depending on the composition, many of these mixed hardwood stands have been plowed, and oftentimes you're walking around, you'll find the rock walls and everything. And then in these areas that were never cleared, frequently they were woodlots, oftentimes wetlands, or dominated by species that were of lower value. So hemlock, which is an eastern species, oftentimes dominated these lands. And there's some other species that did as well. Land use history matters. This is a really great example. People changed the entire composition of this landscape, and it reverted back to forest quickly, but one that is changed in ways that still reflect what people were doing at this time. Wow, wild, right? That's true. Oftentimes, no matter where you look across the world. So I've been showing this photo lately. This is Willow Creek, California. This is a Douglas fir stand here, or a formerly old-growth Douglas fir stand. You can see this big stump here. This is clear cut with the best of intentions of maintaining this stand as a Douglas fir plantation. Silviculture is expensive sometimes. You have to invest if you're going to reestablish, in this case, this conifer species in this stand, because when left to its own devices, it will come back very strongly as a broadleaf dominated stand. That's what happened here. This is extremely dense tan oak regeneration. This is a failure. It's just straight up a failure. This failed the local people, failed in every way. Failed to reestablish Douglas fir, failed on the promise to reestablish Douglas fir and produce timber for the local mills, thereby failing the local people. It is also now a disaster in terms of fuels management. This is so dense, it's got exactly the wrong conditions for carrying a crown fire. Land use history matters, and that includes clearing of lands. Here's another example, just to be complete. This is agrarian society in the highlands of northern Vietnam. These are just rice terraces. These oftentimes get maintained for centuries because they're hard to build, and there are ways to maintain them. The people that live in these areas are indigenous people. In this particular area are indigenous people, an ethnic minority in Vietnam. And they also utilize forest resources. And even though you can't see it, the actions of the local people influence the composition and the distribution of biomass within these forests. In particular, there has been some overexploitation of some rare species. And I give credit to the Vietnamese government and their hardworking scientists working with the local people to try to maintain biodiversity in these places. And they're really cool. They're tropical montane forests, are cold and stuff. I really liked it there, and I really hope that it's maintained in perpetuity, even if I never get to go back. Here's another example essentially of a failure, one that we didn't know was coming. This is an abandoned vineyard in San Mateo County that has been where all the land was cleared, the vineyard was abandoned, and has reestablished with French broom. French broom is an invasive species that is very well adapted to fire. It is excluding forest species from reestablishing in this area. So we have a long-term problem that's related to previous forest management. This is a vineyard that had been associated with a seminary. Jerry Brown, former governor, actually attended this seminary, and this seems kind of tragic that the seminary collapsed and the vineyard was abandoned, and now it's this ugly, French broom dominated thing. And I don't know how that'll ever get fixed. It's going to be a real challenge. Okay, so one of the themes that I'm kind of getting to here is that creating and maintaining forests is a very significant challenge. There are many problems that we face, whether it's problems like the French broom and reestablishing conditions that we might want, or reestablishing conditions in places like Willow Creek that sustain and bolster rural communities, a problem that is a significant challenge in the United States, no matter where you look. Okay, and what I want to say to you is that if you are interested in environmental science broadly, and I mean that term to include forestry, but not exclusively, there's a role for you. There's a place for you here. You don't have to be a forester to make a difference. Now, foresters can play a unique role in addressing many of our problems. They can create instruments for harvesting trees, cutting trees, for maintaining forests, reducing fuels, planting trees, overcoming many of the problems that I have been illustrating for you here and now. Foresters also learn to build roads and build and maintain roads, which are critical resources. And also, everyone can do this, helping to keep the public informed and motivated to help out, whether that's supporting some actions on the landscape, actually getting involved in some way. We have many problems that we have not overcome. We lack mills. We don't have a place to send valuable timber when we need to get rid of it in the forest, and that's especially true places like Southern California, San Diego, the mountains around Los Angeles. There's a lot of timber in those forests. It has value, but it's so far away from the mills that it would be a money-losing operation to get it there. So what do we do about that? We have a really tall mountain to climb here, but it's one that we have to do because our livelihood and long-term economic viability, particularly in California, is dependent on it, especially when you think about that in the context of fire. Okay, let's go back and talk about some more basic processes that are associated with succession. Again, trying to give you trying to help you understand why these basic questions in ecology might be especially relevant to the reasons why you're studying this, why you're in this field, not just taking this class, but in this field. So disturbance and force, we're talking about the basics here again. These are events which change structure and or composition of the community, of the stand. Now, what I want to do here, specific for disturbance learning objectives, I want to distinguish between the consequences of disturbance duration. So how long does the disturbance event last? Is it relatively discrete, or does it happen over a long time? That matters. We are going to identify some common disturbance which shape forest ecosystems. I think you can guess what they are. Some of them maybe not. And we're going to assess how dramatic changes in forest community structure can be given a given disturbance intensity. So here's Vietnam again. This is in the lowlands, closer to Hanoi. This was a forested land, and it's being developed for as part of a tourist infrastructure for an important temple in the area. when you build a parking lot, pretty severe disturbance. There's still going to be some forest here. It'll be kind of an urban forest, but the disturbance is pretty intense. Here's another example. This is from Arthur's Pass National Park in South Island of New Zealand. There are a number of disturbances that are occurring here that are both very discrete in time and long-term, or at least they are happening repeatedly. There are two that I'll point out. One is the river systems. These flood quite dramatically in the spring and sometimes in the winter. I took this photo in late fall. I couldn't get across these rivers because they were just too high by that point. But that scouring of these channels maintains these open areas as unforested. So that's a disturbance that is maintaining this structure as non-forested. Up at the top of this drainage here, there's actually a glacier, and the scouring that's associated with that glacier also maintain this area as unvegetated. There are other kinds of disturbance. This is Popocatépetl, a major volcano that's near Mexico City. It does erupt occasionally, and volcanic eruptions. Most of the slopes of this thing are unforested because it's really tall. It's 18,000 feet, so it's a lot of the forest, a lot of the mass of the mountain is above tree line. However, volcanic eruptions do influence the distribution of forests, and one of the best examples is Mount St. Helens. Blew up in the early 80s after a massive earthquake. And this is an example of something that isn't really that common. Happens with volcanoes to some degree. Happens with glaciers. This is what we call primary disturbances. Relatively few disturbances are like this. It's a condition where the entire ecosystem is reset. So all of the soil is scoured, or in this case, the entire forest ecosystem in a particular area, parts of the downslope from the eruption, were buried in pyroclastic flows, vaporized all the organic matter in the soil and in the vegetation, blew down all the forest, and buried everything that was there that would typically maintain or allow forests to become reestablished. Seed banks, for example, any living trees, lots of the microbial community. I say the true primary disturbances are relatively uncommon because most of the time they can't kill everything. There's something still there. They miss individual trees, or there's still microbes there and so forth. And those things are important for reestablishing communities. However, if you're going to say that something's a primary disturbance, well, Mount St. Helens is probably about the closest you're going to get. This was a massive, massive pyroclastic flow, a massive flow of ash. And it vaporized everything. This rock is on fire. Or this lava is on fire. You know what I mean? It just reset everything down on the mountain. However, most disturbances are not like that. And most of the ones that we confront, the primary disturbances are exceptional. Most disturbances that we see are what we might call secondary disturbances or partial disturbances. They are actions that are shaping the structure and composition of forests, but not resetting the entire system. Here is an example of timber harvesting in Mesoamerica. And this particular example is in Guatemala. What's happening here? Local community is cutting trees. They're processing the timber in the forests. They are not cutting all of the trees. They cut enough trees that you can see stumps, you can see variation in forest structure. The biomass, the distribution of trees, everything is being influenced by the disturbance, which is management. But it's very different than a volcano. Individual trees are being removed one at a time. That means that this system is largely maintained as a forest. It is maintained as a forest. This is a kind of a savanna-like forest that occurs at high elevations. Now, the disturbance that I figured, the first one to come to mind, living in coastal California, is of course fire. And although fire can be quite intense, I want to make the point here that it is also not necessarily, it's rarely a primary disturbance. Many things survive even the most intense fires in California, whether that's seed banks that are adapted to fire, or individuals that are adapted to fire through resprouting, and so forth, or simply the rapid ability to recolonize from populations that are nearby. Many of our plant community, this is a fire-prone landscape, and our plants reflect that evolutionary pressure on them. And here's two last ones that are probably on your mind. We had this massive bark beetle outbreak in the last decade in California. It killed many, many trees, killed trees over the course of about a decade, millions of trees, 300 million trees maybe, over the course of a decade, but didn't kill them all, and didn't kill them all at once. Created a lot of problems, lots of dead fuel, lots of dead trees, reduced forest biomass, but the Southern Sierra, which was particularly hard hit here, this is a photograph from the Southern Sierra in the Needles area, it is still a forest. This area burned this year. Typically, we go to this site in this class, which we cannot this year because of COVID, but we can't for a second reason because it burned this year. But what I expect the next time I get to go is that it will look very different, but it will still be a forest because the systems are adapted to that. Here's another example. This is from Big Sur, and this is illustrating the impacts of an invasive pathogen, sudden oak death. That's the disease. The pathogen is Phytophthora ramorum. Phytophthora ramorum kills certain species of plants, coast live oak and tan oak, but all of the other species are not killed by the pathogen, and so this is still maintained as a forest. In fact, this pathogen kills millions of trees, 50 million about so far, we think, but it hasn't killed, it's not even right to say that it's killed all the tan oak, by no means has it killed all the tan oak. Which is kind of scary because the disease could get much worse. But here, right in the middle of the center of this photograph, there's a patch of living tan oak. This photo was taken about 6 years ago, so who knows? But many disturbances, whether it's bark beetle or an invasive pathogen like sudden oak death, they're incomplete. This is maintained as a forest. There are many dead trees, and tan oak is less abundant, both in terms of its prevalence and its biomass, but it's still there, and that's a big difference between this and primary disturbances. Okay, so last point. Let's look at dominant disturbance regimes broadly. In general, adaptability of stands is critical to retaining functions or composition. And most forests are usually what you should expect when you look at a forest that is completely new to you, wherever it is in the world, that there will be adaptations within it that are a reflection of the dominant disturbances that occur in that area. So what are those dominant disturbances? Well, for example, in the western U.S., it's fire. There's many dry environments, and without adaptation to those conditions and frequent fire, you cannot maintain resiliency. So it could be resprouting like you're seeing in this photograph here. This is a colleague. He is pretty miserable because he's having to work in this. This is post-fire conditions in Big Sur. But I want to point out, it's not just fire. A land use history in the eastern U.S. and Europe has been a major, and in many places, an ongoing disturbance that shapes forests. How is that changing adaptation? Probably influencing the evolution of natural systems. When you look elsewhere, British Columbia, Siberia, and many tropical forests, especially places like Puerto Rico and even Florida, where you have these cyclonic storms, they're adapted to wind events. And then even other parts of the world, and the one that always comes to mind for me is maritime Canada and northern Maine. Oftentimes the main disturbance event will be some native biological species, like insects or some diseases.